NASA's James Webb Space Telescope has just seen the oldest black hole ever observed, dating from the very dawn of the universe, more than 13 billion years ago. In this video, we will explore this amazing discovery, which is located in the galaxy GNZ 11, the most distant and oldest galaxy known. This discovery is important and exciting because it challenges our current understanding of black hole formation and growth, and it could shed light on the early universe and the reionization era. We will answer the following questions. How did James Webb detect the black hole? What does this discovery tell us about the early universe and the reionization era? What are the implications and the future prospects of this discovery? So, if you are curious and fascinated by the mysteries of the cosmos, then stay tuned and watch this video till the end. The black hole and the galaxy that host it are very far away from us, more than 13 billion light-years away. This means that the light that we see from them today was emitted more than 13 billion years ago, when the universe was only 400 million years old. To put this in perspective, the universe as we know it from current theories is now about 13.8 billion years old. So we are seeing the black hole and the galaxy as they were when the universe was only 3% of its current age. This also means that the light that we see from them has been stretched by the expansion of the universe, shifting it from the visible to the infrared spectrum. This is called the redshift, and it is a measure of how far and how old the objects are. The higher the redshift, the farther and the older the objects are. The black hole and the galaxy have a very high redshift of 11.1, which is the highest ever measured for any object in the universe. But how did James Webb manage to see such a distant and faint object? The answer is by using the gravitational lensing effect. This is a phenomenon that occurs when the light from a distant object is bent and amplified by the gravity of a massive object in the foreground, such as a galaxy cluster. This creates a distorted and magnified image of the background object, like a cosmic magnifying glass. Webb used the gravitational lensing effect of a galaxy cluster called MAX J 11495 plus 2223, which is located about 5 billion light-years away from us, to boost the signal of the black hole and the galaxy by a factor of 50. This allowed the US to capture the image and the spectrum of the black hole and the galaxy with unprecedented clarity and detail. By analyzing the image and the spectrum of the black hole and the galaxy, Webb was able to measure the mass and the accretion rate of the black hole, and the distance and the age of the black hole and the galaxy. The mass of the black hole is 1.6 million times that of our Sun, and the accretion rate is the amount of matter that the black hole is swallowing from its surroundings, which in this case is very high, about 10% of the Eddington limit, which is the maximum rate that a black hole can accrete without blowing away the incoming matter with its radiation. This rate is so high that it is eating its host galaxy to death, consuming more than 100 solar masses of gas and dust per year. The distance and the age of the black hole and the galaxy are determined by measuring the redshift of the light, as we explained before. So both objects combined are the most distant and the oldest objects ever observed, dating from 400 million years after the Big Bang, more than 13 billion years ago. So what does this discovery tell us about the early universe and the reionization era? The reionization era is the period when the first stars and galaxies ionized the neutral hydrogen gas that filled the universe after the Big Bang, making it transparent to light. This era started about 400 million years after the Big Bang and ended about 1 billion years after the Big Bang. It is one of the most important and mysterious phases in the history of the universe, as it marks the transition from the Dark Ages, when the universe was cold and dark, to the modern era, when the universe is filled with light and structure. However, this new discovery is surprising and puzzling because it challenges our current understanding of how the first black holes formed and grew in the early universe. According to the current models, the first black holes should have formed from the collapse of massive stars and should have grown slowly by accreting matter and merging with other black holes. But this black hole is too massive and too old to fit this scenario, suggesting that there might be another way to form black holes in the early universe, such as the direct collapse of dense gas clouds. It is also one of the most luminous objects in the universe, emitting a huge amount of energy and radiation, which could have a significant impact on its environment and on the reionization process. As you see, this discovery could reveal a lot of information about the early universe and the reionization era, such as the properties and the evolution of the first galaxies and stars, the sources and the mechanisms of the reionization, and the origin and the diversity of the black holes. The black hole could be one of the sources of the intense ultraviolet radiation that ionized the hydrogen gas, and could also provide clues about the formation and the structure of the galaxy that hosts it, which is the most distant and the oldest galaxy known. The galaxy, GNZ 11, is very small and compact, with a diameter of only 3,000 light-years, compared to the 100,000 light-years of our Milky Way. However, it is also very bright and active, forming stars at a rate of 20 solar masses per year, compared to the 1 solar mass per year of our Milky Way. So it also could be one of the first galaxies to form in the universe, and could represent the building blocks of the larger galaxies that we see today. Now let's talk about the implications and the future prospects of this discovery. It is a remarkable and groundbreaking achievement that challenges and enriches our understanding of black hole formation and growth, and that could shed light on the early universe and the reionization era. This discovery shows that there is more diversity and complexity in the population of black holes than previously thought, and that there might be new physics and mechanisms involved in their origin and evolution. It also opens new avenues for research and exploration, as it motivates further observations and studies of this black hole and other similar objects, using James Webb and other telescopes to test and refine our theories and models, and to learn more about the history and the nature of the universe. It also inspires and fascinates us, as it demonstrates the power and the potential of James Webb and other scientific instruments to unveil the secrets and the mysteries of the cosmos, and to expand our knowledge and our imagination. We have reached the end of this video, and we hope you enjoyed it and learned something new. We have talked about the amazing discovery of the oldest black hole ever observed, located in the galaxy GNZ 11. This black hole is a window to the past, a witness to the dawn of the universe, and a challenge to our theories and our imagination. What else will James Webb reveal to us in the future? If you want to find out, make sure to subscribe to our channel and hit the bell icon to get notified of our upcoming videos. Thank you for watching, and see you next time.